I'm sorry about that. Our first video got interrupted by the bell, so let's take a look at what strategy number 1 is really asking you to do. So let's start over from the beginning. It asks us to graph the line and count to the y-intercept. And so this is our first strategy. If they give me the slope and a point, I can plot the point like we did already. This was 5, -2, and from there I'm going to count the slope. Now technically I would go down 3 and right 5, but that's going to take me off my graph. So instead I'm going to go up 3, 1, 2, 3, and left 5, which puts my y-intercept right here. And then I'm going to connect my dots. You can get a straight edge to help you out with that if you need. And when I connect my dots, I know that my y-intercept is at 1. And I only know that because I counted the slope. So my equation is going to be y equals, we're in slope-intercept form, so I'm going to do -3/5 times x plus 1. Now this strategy wouldn't work if I didn't hit this exactly. And so if I got like a fraction in there, then this strategy of graphing the point and then counting to the y-intercept using the slope is probably not going to work. So we need a second strategy that works more consistent. Strategy number 2 is the one that you've likely learned in Algebra 1. If I give you the slope and a point, you can plug the point and that slope into slope-intercept form and use it to solve for the y-intercept. So instead of counting to the y-intercept, we'll solve for the y-intercept. So for example, my m here is 1/2. My point has an x value and a y value, and so I'm going to plug that into my slope-intercept form. So if I have y equals mx plus b, I'm going to replace the y with 3 equals my m with 1/2 times my x, which is 2, plus b. So then to solve this, I'm going to say half of 2 is 1, so 3 equals 1 plus b, and then when I subtract 1 from both sides, I get that b equals 2. Now I know both my slope and my y-intercept, and I can simply plug it into my equation. Y equals 1/2 x plus 2. So that's strategy number 1. Number 2. Strategy number 1 asks us to graph the point they gave us and count towards the y-intercept. That only works if the y-intercept is a whole number. Down here, I started with my slope-intercept form. I plugged in my slope, which they gave me in the problem, and I plugged in the x and y coordinates from that point. The third strategy is the one I actually prefer. I recommend using this one, but it requires you to know point-slope form, and so that part is a little bit different. Point-slope form is y minus y1 equals m times the quantity x minus x1. And so in this case, I'm going to plug in my slope just like before, so m equals -3. But now I'm going to call this x1 and this y1. I'm going to plug that information in. So into this equation, I'm going to write y minus a -1 equals -3 times the quantity x minus a -2. I plugged in -2 for x1 here, and I plugged in -1 for y1 here. Well, anytime I see minus a negative, I can change it to adding a positive, plus, 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 plus. So really I have y plus 1 equals -3 times the quantity x plus 2. If I want to transform this into slope-intercept form, my next step is to distribute. So I'm going to get y plus 1 equals -3x, and -3 times 2 is going to be -6. And then I'm going to subtract 1 from both sides, and I get y equals -3x plus, I'm sorry, not plus, that's a minus 7. So my equation here is y equals -3x minus 7. I like this one because I don't have to solve for something and plug it back in. I just plugged in the information they gave me, and then I rearranged it, first by distributing, and then moving this value to the other side, in order to get the equation in slope-intercept form. You get to choose which strategy works the best for you, but make sure that you feel confident in at least one strategy.